Okay, so let's look at this question, number 7. Okay, in this question, we've got a ball being projected so that it hits a target up here, having been projected at the square root of 27 ag. 27 ag, that's the initial velocity. Okay, and we know that that is at an angle of theta. We are also told that this target is at a height of 6a and a horizontal displacement of 9a. Okay. And then we're asked to show that tan squared theta minus 6 tan theta plus 5 is equal to 0. So this seems to come from nowhere, but what we can do is we can write down an equation for the displacement at time as it moves through this through this path. So we can write down an equation in the horizontal direction. Now horizontally there is no acceleration. The acceleration is 0. Okay, that's as the ball moves, it moves at a constant velocity horizontally. So it's a very simple equation. It's just S is equal to ut. The displacement is just the initial velocity in the horizontal direction times time. So we need the initial velocity in the horizontal direction. So this is the horizontal part of this triangle. Okay. So that is just 27 ag, but then we want cosine of the angle, okay, multiplied by time, and the displacement is 9a. So at this time the ball is here, and when the ball is 9a horizontally, it is also 6a vertically. So if we look vertically, this time of course the acceleration is not 0, it's slowing down at minus g. So if we have to use another CVAT equation. S is equal to ut plus a half a t squared. But we'll have to look vertically. So vertically, the displacement is 6a. The initial velocity is 27 ag. But this time, sine theta minus a half g, and I've missed out a t there, haven't I? So it's ut, so it's sine theta t, a half minus a half g t squared. So what we have here are two equations that give me the position at different times. As the time changes, this will give me the position. But we know that when the position is 9a horizontally, it's also 6a vertically. So this time here, these two times are the same as this time. Okay, those times are the same. So if we take this equation, number 1, number 2, and do from number 1, t is equal to 9a over 27 ag cos theta. That is my time. Okay, and now I can take this time and substitute it into these times. Okay, so substitute into 2. So I've got 6a is equal to 27 ag sine theta, mustn't forget my square root, t is 9a divided by 27 ag cos theta. Okay, so this is immediately going to look a little bit nicer now, isn't it? Because we can cancel this, and we've got sine theta divided by cos theta. That's looking good, because our equation that we want to get has got tan thetas in it, so it looks like we're making progress. Okay, minus a half g, t, that's t squared. So it's this squared, half g times 9a over 27ag cos theta, and all of that is squared. So we need to have a play around with this and try and make it look like this. Okay, let's have a go. So we can see over here, you can cancel the 27 AGs, and so we've got 6a is equal to sine theta divided by cos theta, that's our friend tan theta, times 9a. Okay. Now, let's tidy this up a little bit. Minus a half g, or 9 squared, 81 a squared, over this squared. So that's 27 ag square rooted, but then squared again, okay, cos squared theta. Okay. So again, we can do this tidy up a little bit here. We can get rid of one of the a's. We can get rid of a g. 81 over 27, I think, is 3. Okay. So we've now got, can you still see that on the corner there? Yeah, just about. 6a equals 9a tan theta minus 3a over cos squared theta. Sorry, a half of 3a over cos squared theta. Okay, so now we need to play around with this cos squared theta a little bit. Okay, let's just bring in a little bit more whiteboard for us there, so that we can see that. Now, one of the things that you should know is that 1 over cos theta is known as sec theta, and you should also know that sec squared theta is equal to 1 plus tan squared theta. Okay, those are two identities that you should know, and it might be in the formula booklet as well. Okay, so we can actually use that in here. So I've got 6a equals 9a tan theta minus 3 over 2a, 1 over cos squared. So 1 over cos squared theta is equal to sec squared theta, but then sec squared theta is 1 plus tan squared theta. So 1 plus tan squared theta. Okay. Oh, it's something else we can cancel nice and neatly here. We can get rid of all those a's, can't we? I didn't spot that before. Okay. And we can also, because it's the multiples of 3, so we can divide by 3 and multiply by 2. So divide that by 3, I get 2, but then I'll get 4 back. So I multiply by 2. Divide that by 3, I'll get 3 times 2 is 6. Tan theta minus 1 minus tan squared theta. Okay. Multiplied that out. And now we just need to collect it because we want it in the form of tan squared theta minus 6 tan theta. So tan squared theta minus, because that's 6 tan theta, taking that onto that side, so it's plus 5 is equal to 0, which is what they want you to prove. Okay.